All right, Lasia, here you go. I went ahead and I'm going to make a video of my own on those one questions that we were looking at. I'll try to do the other two tomorrow, okay? It's getting kind of late. It's already almost 9 o'clock. All right, so the one thing you had, it gave you tan theta was 4/5, and it wanted to know all the ratios of the others. Now, if you remember, we went back to our regular triangle, and tangent is opposite over adjacent. So the side that's opposite this is over here, so that becomes my 4, and adjacent is 5. Once I have those two, I got to figure out this one. Once I figure out that, I can fill in that whole chart. So remember, if I have two sides of a right triangle, I can find the third by using Pythagorean theorem. So I'm going to say 4 squared plus 5 squared equals I don't know squared. Okay, 4 squared is 16, 5 squared is 25. And so I add those together, that's 41 equals c squared. Then I can square root both sides. So c would equal the square root of 41. So I come up here, and instead of a question mark, I'd say the square root of 41. Okay. All right, so sine. Sine is opposite 4 over hypotenuse, square root of 41. Now remember, I told you when we were looking at this earlier, they don't like this square root in the bottom. They'll call it rationalizing the denominator. A lot of big words. It just means get rid of that square root in the bottom. I'm going to show you the math because we have more time, and you can rewatch this. So I'm going to have to multiply by whatever's on the bottom, square root of 41. But if I do it on bottom, I have to do it on top. So then I multiply across. That'd be 4 square roots of 41 over, if I multiply those and then take the square root, I'm just going to get 41, okay? So my sine would then be 4 square roots of 41 over 4, okay? All right, cosine. Cosine, remember, is adjacent over hypotenuse. So cosine theta adjacent 5, right, over hypotenuse, square root of 41. It's just like sine. I have that square root in the bottom, so I have to multiply by square root of 41. If I do it on bottom, I have to do it on top. So that would give me 5 square roots of 41 over 41. Okay, that's the math that I didn't show you earlier. So I'm going to put here 5 square roots of 41 over 41. So there's sine, cosine, tangent finished. Now, cosecant is the opposite of sine. So if sine is 4 over square root of 41, then cosecant is square root of 41 over 4. Okay? Don't flip this because then you'll have to re-multiply again, okay? Secant is the opposite of cosine, which was originally 5 over the square root of 41. So secant is square root of 41 over 5. And then cotangent is the opposite of tangent, so it's 5 over 4. So that's that first one completely done. Okay, now give me just a second. I'll do the next one because you had a different one. Erase all this info because it looks a little different. Same concept, same process, but I want to make sure there's no questions for you, okay? I think this was number 10 was the next one. Give me just a second. Erase all this stuff. So I have to rewrite all this. All right, so number 10, it gave you cosecant was square root of 7 over 2. Okay, square root of 7 over 2. Okay, so cosecant is the opposite of sine. So it's hypotenuse over opposite. So if I come over here, hypotenuse would become square root of 7 over opposite, which is straight across, which would be 2. Now here again, if I have two sides, I can use Pythagorean theorem to figure out the third side. Now this time, I don't have one of my sides. Earlier, I didn't have my hypotenuse. So 2 squared plus I don't know squared equals the square root of 7 squared. Okay? 2 squared is 4. And square root and square cancel each other, so I have 7. I'm going to subtract 4. B squared would equal 3. So square root both sides. B would be the square root of 3. So that's what this is here, right? Does that make sense how I figured out that? Okay. So then I'm going to plug that stuff in to all my ratios. Okay, I'm going to erase this because get it out of my way. Okay, so I have all my side lengths. So let's start with sine. We'll just work our way down. Sine is opposite 2 over hypotenuse square root of 7. So 2 square roots of 7. Now, remember, I don't like a square root in the bottom, so I have to multiply by the square root of 7. If I do it on bottom, I got to do it on top. So that'd be 2 square roots of 7 over 7, because 7 times 7 is 49, and square root of 49 is 7. So that becomes my sine, 2 square roots of 7 over 7. Okay? All right, cosine is adjacent over hypotenuse, square root of 7, 3 over square root of 7. I don't like that in the bottom, so I'm going to multiply by the square root of 7. Okay, now these numbers I can multiply. That'd be the square root of 21 over 7. Now you can't reduce that because that's not in the square root. So I'm going to bring that over, square root of 21 over 7. Okay. Once I have all 3 of these, then I can fill those in pretty quick. Okay. Then tangent is equal to opposite over adjacent. So 2 over the square root of 3. Can't have a radical square root in the bottom, so multiply by it. That gives me 2 square roots of 3 over 3. So that becomes my tangent. Okay, so secant. Secant, we're still going to have to do some math. But cotangent, if tangent is 2 over the square root of 3, cotangent would be square root of 3 over 2, right? So I don't have to do anything else there. Now, secant, it's the opposite of cosine. So it's going to be square root of 7 going to be the square root of 7 over square root of 3. I got to get rid of that in the bottom. So multiply by whatever's in the bottom. Don't worry about the top. So that'd be square root of 21 over 3 this time, right? Because 7 times 3 is 21. 3 times 3 is 9. Square root of 9 is 3. So secant would be square root of 21 over 3. So that is that 9 and 10 at the top of that one page. I hope this helps.